The next paper presentation is, the title is Role of PKI for Securing AMQP Communication. And the author is Mr. Sanjay. Please.
Yeah. Good morning and thank you. My paper title is Role of PKI in Securing AMQP Communication. So here what exactly we have done? We have explored various attack vectors of AMQP protocol, and then we demonstrated how AMQP can be targeted. Some of the attacks what we have demonstrated. And then finally we suggested how PKI will be involved here to secure this particular AMQP communication. So this is the agenda of next 10 minutes. I'll talk about AMQP and then what are the various threats which are actually involved in AMQP communication. Followed by the attacks which we have performed here in this particular paper, the dictionary attack, DOS attack and MITM attack. And then I'll focus on how PKI can actually mitigate those attacks. And finally, we'll be showing what challenges which are there with respect to AMQP, and we can conclude our this particular talk. Now, if you see, all of us, we are using internet heavily. Almost 8 hours we are spending browsing internet. Now, the way internet has reformed the world, we cannot hardly envisage our life without it. Again, if we see that we are living in the era where various objects are interconnected, and these objects are uniquely identifiable. They can actually sense, they can actuate, they can communicate without any interaction of human. So if you see, we have around 62 billions of IoT devices in the world, and which is outnumbering humans. Humans are around 8 billion. Now, one study says that we have around 150 billions of IoT devices by 2030. Now, if you talk about AMQP, we have application layer protocol, which does device communication. And we have a lot of protocols like HTTP, we have CoAP, we have MQTT and AMQP. And if you see about AMQP, this is the protocol where actually it uses publisher and subscriber model. Like if you browse YouTube, the YouTube has one publisher, and the people who is actually browsing that particular channel, they can see. So here, same things, same concept is used here in AMQP communication. You have one publisher, and then you have a consumer. In between, we have something called a broker, which will actually exchange the message between queue and like various queues. Now, this particular slide shows that how the AMQP can be targeted. What are the various attack vectors of AMQP protocol? Starting with if AMQP is not secure, like default configuration will be there with the AMQP, right? So in that, a lot of attacks can happen actually. I'll be showing what we have done with this kind of default configuration, where we are using an RabbitMQ application, and that was default configuration was done on that, and then we performed some dictionary attack. Again, if you see, we have something called interception and manipulation of messages with respect to AMQP attacks. So here actually what we have done, we have performed one attack called MITM, man in the middle attack, and we shown that how the AMQP communication can be targeted. So from broker to say publisher or subscriber, we can get the communication detail actually very, very easily. And again, we have demonstrated one more attack called denial of service. So how this AMQP communication can be broken, can be made unavailable. That also we have shown. And apart from that, lot of attacks are there with respect to this particular protocol called AMQP. As I told you, we actually performed 3 attacks mainly. One is a dictionary attack, other is a denial of service attack, and man in the middle attack. So as I told you, here we used AMQP application, which is actually called RabbitMQ server. And on that RabbitMQ server, this is the default configuration which we have done the setup. And on that, actually, we have performed this dictionary attack, and we got some username and password from that AMQP, particular RabbitMQ server. And again, we performed DOS attack where we have used one Kali Linux tool, Zero Exploit. Using that, we performed this DOS attack, and we made this particular application unavailable for the user. And we also performed MITM attack using something called ARP cache poisoning. And there we could see the message which is going between a broker and actually subscriber. So this is the first attack how we have performed here. As I told you, we use something called Kali Linux. So in this dictionary attack, the RabbitMQ server was there, which we have configured on one of the system. And then on attacker's machine, what we have done, we did the scanning on that machine, and we got to know that AMQP actually is running on the particular machine. And we used Nmap for seeing what the version of this particular RabbitMQ is there. So once we got to know that, we got to know that these are the default configuration of RabbitMQ. These are the default username and password which can be targeted. So we created one Python script or Python program. Using that, we can perform this kind of dictionary attack. And once we have performed the attack, we've got to know all the users which are part of that particular RabbitMQ server. Now, next is DOS attack, how we have performed here. As I told you, we used Zero Exploit, one tool which is by default installed in Kali Linux. And the first thing what we have done, we started executing that tool and then scan for the devices in the network, which was shown here in that slide. And once we got to know this is the target, we set the target and we use one module called DOS module as a part of this Zero Exploit or Zero Exploit tool. And we sent around 191 lakh packets to that particular RabbitMQ server, and we got to know that that server stopped working, right? So DOS attack was successfully performed. And the third attack, what we have demonstrated in our paper is man-in-the-middle attack. So here, as I told you, we use ARP cache poisoning, and in that actually one tool was used, EtherCap. And that EtherCap tool is by default then as a part of your Kali Linux. And once we executed the tool, we set two target. One is broker and other is publisher. So we wanted to capture the communication between broker and publisher. And we set one parameter called sniff mode connection. And then we launched this attack. So once we successfully launched this attack, all the traffic between, say, broker to publisher, we were able to see, right? If you can see in this right-hand side image, right? So hello world, which was sent from, say, publisher to broker, we could see in our machine. So we successfully performed this attack, compromising the integrity and confidentiality of this AMQP communication. Now, let us see how the PKI will mitigate those kind of attacks. Not all, even DOS, we know that nobody can, DOS or DDoS we can mitigate, but still some of the attack using PKI can be very easily mitigated. So as we know that AMQP is using actually SASL and TSL for encryption and authentication. So integrating PKI into AMQP protocol significantly strengthens its authentication mechanism. So by incorporating digital certificate and cryptographic protocols, PKI provides a robust framework verifying the identities of the communication entities. So this will ensure that only trusted parties can establish the connection, thereby enhancing the overall messaging system and safeguarding data integrity and confidentiality during the transmission. Here, the certificate-based authentication, where we are using X509 certificate, verify the identity of each and every component of this AMQP communication, like broker, you have publisher and subscriber. So as I told you, TLS is used here for encryption and authentication as well, whereas SSL is used here for actually additional authentication, which is called Kerberos and TLM. Now, what are the various challenges which are there here as a part of this AMQP communication to secure? If you see, securing IoT communication using AMQP presents several challenges due to the nature and requirement of different IoT devices in the network. Again, these devices has limited power, limited memory and battery life, which make is hard, which make them more vulnerable to physical tampering and unauthorized access. Again, we have the different kind of devices from different manufacturers, which has own level of security and capabilities. So managing this kind of say task like firmware update, patching, and all is a little bit challenging. So in this, we are concluding saying that our paper actually focuses on what is the role of the PKI for securing this particular AMQP communication. And here we have demonstrated attacks, various attacks. We have identified some attacks, and we have done the demonstration of 3 mainly attacks. And in this, these are the references which I have used. Yeah, so any questions? Yeah, if no questions, then thank you very much.